Alright, so what is the mass percent of hexane in a mixture with heptane if the mole fraction is 0.2? And we actually don't need the figure in this case. It's relevant, but it's related, but not really relevant to the question. Okay, so we've got a hexane, and just as a reminder, this is C6H14. So we've got a hexane-heptane mixture, which is C7H16. And we've got a mole percentage, which is N of hexane over N total, which is 0.2. And it wants to know what MC6H16 over M total, what that is. Okay, so our N total is just the sum of our moles. And I'm getting carried away. Plus that for heptane. Our mass total is then the sum of our masses, which we can write as our moles times our molar mass for each of these species. Okay. Now, if we write our MC6, and we can use the fact that we also know our moles of our mole fraction for C7H16, because if our moles for hexane, our mole percentage for hexane is 0.2, then our mole percentage for heptane must be 0.8, because it needs to add up to 1. So our mass total over our N total is then NC6H14 times over N total times MC6H14 plus N of heptane over N total times our molar mass for heptane. So just using the factors we have, this is then 0.2 plus 0.8, or our mass total is then just 0.2 C6H14 plus 0.8 our heptane mass times our N total. Okay, so now our mass for hexane, I want to get these mixed up, C6H14 over our mass total is then equal to, so our mass for hexane is just our molar mass for hexane, our moles for hexane times our molar mass for hexane over our total mass, which we've just written in this way. So I'm actually going to bring the end total out front just to make it obvious. Okay. And now out front here we see we again have our mole fraction of hexane. And so then that's just 0.2 times our molar mass of hexane over, and so now we have it completely in terms of our molar masses. And so we can now readily figure out what our mass percentage would be. So our molar mass for hexane, or first actually our molar mass for carbon is 12.01 grams per mole, and our molar mass for hydrogen is 1.008 grams per mole is what I'm going to use. So our molar mass for hexane is 6 times 12.01 plus 14 times 1.008, which is then 86.172 grams per mole. And our molar mass for heptane is going to be 7 times 12.01 plus 16 times 1.008, which is then 100.198 grams per mole. All right, so there's our molar masses. We have our equation for our mass percentage. So then mass percentage of hexane is going to be then 0.2 times our molar mass for hexane, which is 86.172 grams per mole, all over 0.2 times 86.172 grams per mole plus 0.8 times our molar mass for heptane. Okay, and then working through this on our calculator, we get 17.2344 on top, and oh, I guess I wrote it right out, so 80.1584, and then working through this on our calculator, we get 0.1770, or in percentages, so multiply by 100%, and it's 17.70%. So our mass percentage is 17.70%. So now going through the solution here, assume a mole of mixture, so that's fine. If it helps to do it that way, that might be easier. So we just solve for a mole of mixture, and because it's going to be a percentage, then it should be unitless anyway, so it doesn't matter what volume or what moles you choose to work with. So if you work with a mole, well, your mole fractions are still going to be the same. You'll get an amount of grams, which is fine, and so you'll get a gram, a mass amount for this fictional number of moles, but then the mass percentage will always carry over, and it comes out to be 17.71%, but that's likely just either rounding errors or differences in choice of our just number of decimal places. So, and also likely choices, it looks to be difference in molar masses used for carbon and hydrogen, just because hexane comes out to be 86.18, whereas I've got 0.172. And yeah, so it's likely just differences in molar masses. But the solution, I would say, is correct.